Authentication tells us who someone is. Authorization decides what they're allowed to do. In this module, we'll connect familiar web concepts like roles, permissions, and attributes to Web3 wallets, addresses, and smart contracts, so access control stays safe and understandable. You now have the foundation. Blockchains protect data, cryptography proves identity, and wallets let users authenticate without passwords. The next step is authorization, using that verified wallet identity to decide what someone can access or do. Authentication and authorization are closely related, but they solve different problems. Authentication proves who is making the request, such as by signing a message with a wallet. Authorization decides what that authenticated wallet can actually do. It might allow data access, block an admin change, or require a smart contract rule. A wallet address should never mean automatic full access. Permissions still need to be enforced in the interface, on the server, and in contracts. A protected action starts the authorization flow, like viewing data or submitting a transaction. The system confirms who the user is using a session, wallet address, or other proof. Then it loads the facts that matter: roles, attributes, ownership, balances, or token state. Policies compare those facts with the requested action. The answer may be yes or no, but sometimes the safest response is to ask for stronger proof before continuing. RBAC keeps authorization manageable by separating users from individual permissions. Instead of assigning every action to every person, you assign a user to a role, such as admin, editor, member, or viewer. That role carries the allowed actions. An admin might manage users, an editor can change content, and a viewer can only read. RBAC works best when responsibilities are clear and access rules are fairly stable. ABAC makes access decisions by evaluating attributes, not just roles. The system can ask, who is the user? What resource is being requested? What is happening in the environment? And what does the blockchain say? Access might require a verified account, ownership of a document, a low-risk score, and a required token balance. This makes ABAC powerful for Web3 apps where permissions often depend on live changing conditions. RBAC and ABAC are not rivals. They fit different access problems. Use RBAC when roles are stable, like admin, manager, or employee, and you want permissions that are easy to review. Use ABAC when access depends on live conditions, such as account balance, ownership, location, or subscription status. The trade-off is complexity. ABAC is more flexible, but every dynamic rule is also something you must test, explain, and debug. Hybrid authorization is often the practical middle ground. A role gives a clear baseline, like member or editor. Attributes then narrow the decision: owning this project, holding a required NFT, maintaining a subscription, or meeting a token balance. In CreatorDAO portal, publishing might require contributor status and at least 100 tokens. This keeps policies understandable while still adapting to Web3, DAO, and SaaS community rules. Once a wallet is connected, the public address becomes the handle the system can reason about. Permissions can then be resolved in 3 common ways. A backend database can map an address to roles like admin or VIP. A smart contract can store permissions directly on-chain. Or the app can query blockchain state, such as token balances or NFT ownership, and use those results as dynamic access attributes. With off-chain permission mapping, the app keeps roles in a normal database, tied to a wallet, account, or subscription. The backend reads that record, then applies logic such as, if this user is an admin, allow the action, otherwise block it. This is fast, cheap, and easy to change because no blockchain transaction is needed. The trade-off is trust. Users cannot independently verify enforcement the way they can with on-chain rules. With on-chain permission mapping, the smart contract becomes the gatekeeper. When someone calls a protected function, the contract checks MSG sender against a role, whitelist, or token balance before allowing execution. That makes access rules public, tamper-resistant, and easy to audit. The trade-off is flexibility. Changing permissions can require transactions, gas fees, or even contract upgrades, so these checks need careful design before deployment. Authorization checks can happen in 2 very different trust environments. On-chain checks are best for irreversible actions like transferring tokens, minting, or changing contract state. They are public, tamper-resistant, and enforced by the network, but every check adds gas cost. Off-chain checks are better for dashboards, private data, feature access, and user settings. They are fast and adaptable, but users must trust the backend to enforce them correctly. Token gating turns wallet ownership into an access rule. A community might require a specific NFT pass. A DAO portal might require 100 governance tokens. A content site might use a snapshot list, so access does not change every time tokens move. The application checks the chain, or an indexed copy of it, then grants or denies entry. The key design questions are what counts, when it is measured, and how much privacy users give up. A strong permission policy starts before code. First, name the protected resources and the actions users can take, such as mint, transfer, update, or withdraw. Then define who qualifies, by role, account attributes, ownership, or token state. Next, choose the enforcement point. Some checks belong in the interface, others in the backend or smart contract, and many apps use a hybrid. Finally, document each rule plainly so it can be tested and audited. Authentication proves wallet control, but authorization decides what that wallet may do. RBAC keeps decisions simple with roles, while ABAC adds flexibility through conditions and context. Permissions can come from databases, smart contracts, or blockchain state. Next, we'll examine the security and privacy risks behind these choices.